You guys looked at animals recently? Well, I have been, and you know what? I've been seeing some weird stuff, and, well, not that weird, first of all. But you know what? I've been seeing some duplicate animals. Some clones, if you will. And it's got me thinking, maybe we were in a simulation or something. Nah, that can't be the case.
Yeah, that's good enough.
Convergent evolution is when two completely unrelated species evolve and occupy a very similar niche and therefore develop very similar traits. This could be in the form of color, behavior, maybe the function of a body part, or even an exact replica of the organism. Well, maybe not the exact, but you know what I mean, pretty close. Convergent evolution is like when you're sitting there at a dinner table and you ask your mom,
"Mom, can I go see Snoop Dogg? There's this new concert I just really wanna go."
Honey, we have Snoop Dogg at home.
Sugar gliders and flying squirrels make a great example of convergent evolution. Both distinct species develop similar adaptations due to their similar environmental pressures. Despite belonging to different taxonomic groups, both sugar gliders and flying squirrels have evolved the ability to glide through the air using a thin membrane called the patagium. Yeah, you could say many animals develop flight over time, but this precise development of skin parachutes between their limbs, not only do they look the same, but they're functionally the same exact thing. And this goes beyond a mere coincidence. It's like Mother Nature went out and said,
"You see those flying squirrels over here in North America? Yeah, we got those on the other side of the globe. You see, I only had like 50 million years for this little science project, so I had to do a little copy and paste work."
Going into the water, we can see dolphins, sharks, and ichthyosaurs, completely unrelated. One's a mammal, one's a fish, and one's an extinct marine reptile. They all share this like torpedo body with fin-like appendages, a powerful tail, and they're just able to move really swift and agile through the water. Something fishy's going on here and I can't really pinpoint it. Another example, snakes. You know I love snakes. You know, anything that evolved from that noodle lineage is my personal favorite. So let's look at the green tree python and the emerald tree boa. Both species are arboreal treetop predators with pretty much the same physical traits from head to tail. The adults of both species show green coloration, helping them blend seamlessly among the green foliage, but the juveniles of both species start with a yellow or red coloration, and then this coloration transforms into the green adults. Everything from coloration to posture to the aggressive demeanor of these snakes is more or less identical, one being from the python family from Southeast Asia and the other being a boa constrictor from South America. So why is it that in nature we see these repeat or copycat species? Is Mother Nature really that lazy, or is something else going on? Well, to answer that, we have to understand what niches are and how they're formed in the first place. A niche is effectively the specialized job of a species. Typically speaking, there's only room for one job for each role in a habitat. These roles are formed by many different environmental factors over a given time, but two notable ones are abundance of food and habitat. First of all, if you're a snake living in the treetops and there's no prey items in the treetops, then you're either gonna die or forced to live in a role not in the treetops. Because you have to survive, that means you have to go where the food is. If the snake was found in an arid desert habitat, the snake would never have a reason to evolve an arboreal lifestyle. In other words, all species are naturally both affected by the environment and at the same time affect the environment for other species. So now that we understand niches and some of the pressures that form them, we can now understand why there's quote-unquote copy and pasting of species. It just so happens that when environmental pressures are similar looking species are likely to appear. It might just be the case that some traits have one ideal solution. It's said that eyes have evolved independently not 2 or 3 times, but 40 times throughout history. And they're not just functionally the same, but almost anatomically identical. For instance, this is an octopus eye, and this is a human eye. And with that being said, I think we can wrap up convergent evolution. If you liked the video, make sure to smack that like button, shoot me a comment or question, check out the description, and subscribe if you haven't already for more wildlife content.